video CA11 in college algebra. This is going to cover chapter 1.6b. Like I told you, I'm going to split this 1.6 up into 3 sections so it won't be so overwhelming. This section talks about adding and subtracting rational expressions, and this is only 2 pages in the book, 86, 87, but I am going to back up a little bit and try to give you a basis for some of this. So let's get in the book and get started. So just a preview, this is where we're headed. This is a subtraction problem with 2 rational expressions. In the last section we learned how to simplify them. So now we're going to be combining them. So let's go old school here for just a second, because if you can really understand regular fractions, doing rational fractions is so much easier. Alright, these are 2 circles that are the exact same size. This circle, think of them as pizzas. This circle was cut into 5 pieces, and this circle was cut into 7 pieces. Now the total is still the same, right? So is this piece the same as this one? It's one of the piece, but no, it's not the same as one of these pieces. So if I wrote a fraction to represent one piece from each of these, this piece is 1/5. This piece is 1/7. Well, if the numerators are the same, what is it about a fraction that makes it different? It's the denominator. The denominator tells you how many pieces a whole thing, whatever it was cut into. That's what determines the size of each piece. Your numerator just tells you how many of those pieces you have. I might have 10. That still just means somebody cut a pizza into 5 pieces and I have 2 whole ones. So your denominator is what's going to determine whether the fractions are similar, whether they are alike. And we know that in order to combine anything, we need similar or we need like terms. So what could I do to these to make them alike? Well, if I took this pizza and I cut one of the pieces into 7 pieces, and then I cut each of these pieces into 5 pieces. All right, let's think about it. If I took 5 slices and I cut it into 7 pieces, how many total slices do I have now? 7 times 5, now I have 35. All right, over here, if I took each one of these 7 and cut it into 5, how many total pieces do I have? 35. So 1/35 of a piece would match, right? Okay, now the thing is, 1/5 is not equal to 1/35, and 1/7 is not equal to 1/35. So once you determine what your common denominator is going to be, you have to adjust the numerator for that size. So let's look. What did I cut these pieces into? 7 more pieces. So now each one piece is in how many pieces? 7, right? And I cut these pieces into 5 smaller pieces. So that means this fraction is 5/35. Okay. Now let's look at a more mathematical way to do this, because you're not going to want to draw a pizza out every time. So let's bump it up. What you're looking for is an LCD, a least common denominator, or a lowest common denominator. What is that? The lowest common denominator is the smallest common multiple between 2, 3, however many denominators you have. What does that mean? Recall the difference between a multiple and a factor. A multiple is a number that the given number goes into, whereas a factor is what the number can be factored into. Well, that didn't help much because I used those words. So let me give you an example. Let's just take the number 12. A multiple of 12 is what you get when you multiply 12 times something else. So 12 times 1, 12 times 2, 12 times 3, 12 times 4. All of these are multiples of 12. They're bigger than the number you start with. A multiple has to be bigger than the number you start with. So now let's look at the factors of 12. What numbers factor to be 12? 1 and 12, 2 and 6, 3 and 4. Your factors, notice that the largest one is the same size as your number. And then they get smaller. So factors are smaller than your number. Multiples are larger. So let's just look at this problem right here. If I want to add 1/25th and 1/35th and 1/15th, the process for doing this, I need to find the lowest number that all three of these will go into. Now, several different ways you can do this, but I'm going to show you the technical way. Factor each one of these into prime factorization. That means break it down into nothing but prime numbers. The prime factorization of 25 is 5 times 5, or 5 squared. The prime factorization of 35 is 5 times 7, and 15 is 3 times 5. Now my LCD for this is going to be one of each factor and the highest power of those factors that are in this group right here. I've got this whole group of numbers. All right, what all bases are in there? Well, I have a 3, and I have a 5, and I have a 7. I just picked one of each base. Now you go back and you take the highest power of each one. Remember, whatever number I come up with, all of these numbers have to go into it. So I have to take the biggest thing I need. All right, there's no exponents of 3, so it stays like it is. Now with 5, I have a 5 squared. So I'm going to adjust this number to be 5 squared, and then 7 is fine like it is. Now, this is my new least common denominator. If you want to multiply them all together and get a big number, you can, but I'm going to tell you, it's better at this point to leave it. You know, whenever you start factoring things, you can multiply it at the last minute. You can make it bigger at the very last step. So leave it factored. It's better than having to, you multiply it, then you got to factor it back. So what I have now, let's look at this. This was my old denominators. I want to change all of these things. I want to adjust them so that they all have this new denominator. So I'm going to write this under each fraction, okay? This is the denominator that I want. Now, how do you convert fractions to be larger? You can do anything you want to a fraction. You can multiply a fraction by anything you want to, as long as you do it to the numerator and the denominator. So let's look at this first one. What did I multiply 25 by, or the 5 squared by, to get over here? Well, what is not here? I have this, so I multiplied it times the 3 and the 7. So that means I have to multiply this numerator times a 3 and a 7. And we'll do the math in a minute. Alright, now let's come to this one. This denominator was 5 times 7. What's my new denominator? Well, it's 3 times 5 squared times 7. So what do I have here that I don't have here? I do not have, let me put the 1, I do not have a 3. Alright, I have a 5, but my new denominator has 5 squared. So I'm going to have another 5 to balance that out. And I already have a 7. Okay? You're looking for what is in this denominator that is not in your previous one. Alright, my last one, I have a 3 times 5. Well, what do I have here? I have a 3 already. I don't need another one of those. Now, just like this one, I have 1 5, but I need another 5. And I do not have a 7. Okay? Now, this should balance out all of these numerators and denominators, so we can do the math at this point, and 3 times 7 would be 21. I'm not going to recopy this just yet, because they're all the same, and that was the goal. Alright, here, this is 15, and here, this is 35. So I can, now notice, they're balanced. If I multiply this denominator all out, it's going to be the same. 21 over this is the same as 1/25. It's like I just took that 1/25 slice and I cut it into a whole bunch more little pieces. So the piece, this number's bigger, the pieces are smaller, but I'm going to have more of them, if that makes any sense. So to finalize this, you would add 21 plus 15 plus 35. So that's going to be 11, 3, 4, 5, 6, 71 over, and I'll have to multiply that together. Anyway, so this is going to be your final answer. Now, like I said, I know that's basic. A lot of you are probably bored right now, but I wanted to touch this base before I go to the next one, because it's a little bit harder to see the process when you have polynomials out there. But let's get some variables into this. So let's look at example 4, page 87. Got 5 over x plus 6 over y. So what I want to do is get common denominators. Even though I don't know what these are, they're not a number, I know they're not the same. So we're going to use the same method. What are my factors? Well, this one is x, this one is y. So I'm going to take one of each factor. So I have xy for this one, xy for this one. I'm creating a new denominator for each fraction in my polynomial. Alright, now let's go back. What does this denominator have over here that this one does not? It has a y. So whatever it has that you're needing, you're going to multiply it times your numerator. So I'm going to multiply that times 5y. Alright, now what does this denominator need? What does this one have that this one doesn't? This has an x. This does not. So technically what I'm going to do is multiply by x over x. Technically what I did over here is multiplied by y over y. Alright, I've already got xy here, so now this is going to be 6x. Alright, now that I have common denominator, I can just write it once and put 5y plus 6x, or you can put 6x plus 5y, either way. Alright, and not too hard. This is going to be your final answer. So looks like my regular fractions were harder than variable fractions right now, doesn't it? Well, let's look at another example. Okay, here's a rational expression. So let's see what we need to do. We need to get a common denominator first of all. And in my first one I have x plus 2, x plus 3. In my second one I have x plus 3, x plus 4. So let's pick out one of each factor. Now remember, factors are multiplied. So what are my factors in this problem? X plus 2, x plus 3, x plus 3, x plus 4. Those are binomials, but they are separate. They're in parentheses, so that makes them a factor. Now, what do I need? Well, I need one of each thing, so I'm going to need an x plus 2 and an x plus 3. Now, look over here. I already have the x plus 3, but I don't have the x plus 4. And let me make this better. Okay. Now your denominator is going to be the same. So whatever this one is, it's the same over here. Okay. So you see I've got the same denominators now. Okay. This represents this first fraction. So what do I have here that I do not have here? Well, x plus 2 and x plus 3. So technically, what I had to do was multiply this by x plus 4 to get this new denominator, right? All right, whatever I did to the denominator, I've got to do to the numerator. What is 1 times x plus 4? X plus 4. Now let's look at this denominator. What was done to go from this denominator to this one? Well, I already had those two things. So what I did is I multiplied this denominator times x plus 2. Whatever you do to the denominator, you have to do to the numerator. What's 1 times x plus 2? X plus 2. Now, you're ready to simplify. Your denominator is now common, so you can just put all this over one denominator, and then we're going to add x plus 4 plus, it's whatever this sign is, don't multiply them. X plus 2. What is x plus 4 plus x plus 2? Well, that is 2x plus 6 all over x plus 2 times x plus 3 times x plus 4. So now, before we wrap this up, let's look at our problem. This is not simplest form. What if you factored this? What would you get if you factored 2x plus 6? Well, you get 2 times x plus 3, right? So let's factor that down. Now I have x plus 2 over x plus 3, x plus 4, and look at there. These two things cancel out. This is from your simplification section we just did. And our final answer here is going to be 2 over x plus 2, x plus 4. Quite a little problem there. Alright, let's look at a subtraction. Last example, number 5 on page 87 in the textbook. So we have a subtraction problem, 6 over x squared plus 4x plus 4 minus 2 times 2 over x squared minus 4. Alright, when you see a rational expression, fractions subtracted, you know you need to find a common denominator, and you know to get that common denominator you need to factor all of these. Okay, so let's get started. Your two numerators, fortunately, don't need to be factored. Sometimes they will, so watch for that. You're going to need to factor everything. Alright, here's a trinomial. Going through those factoring steps from a section ago. You do not have a coefficient in front of your first term, so you are just going to factor this into two binomials. Since this is a plus sign, your signs are the same, and they are, whatever this is. So here's plus and plus. You do, like I said, you don't have a coefficient, so all you have to do is x and x. Now, for the two numbers here, they have to multiply to give you 4 and add up to give you 4. That's pretty simple. If you need to make a chart, you can, but you're just going to have 1 and 4, 2 and 2. So you would pick the 2 and 2 pair, and there you go. Alright, and if you want to rewrite this as x plus 2 squared, you certainly can. Alright, here we have a difference of 2 squares. What is x squared minus 4 going to be? Well, it's going to be x plus 2, x minus 2. Now to get our LCD of this, remember you take one of each factor and the highest power of each one. Here my factor is x plus 2 squared. Here I have x plus 2, x minus 2. Now remember, x plus 2 is not the same as x minus 2. So for our new common denominator, we're going to need one of every factor we see. So I see an x plus 2 and I see an x minus 2. Now I need the highest power. Well, this one has a square. So I'm going to have x plus 2 squared up here and then x minus 2. And this will be the denominator for each one. Now I've got to adjust my numerator. What do I have in this denominator or what do I not have in this denominator that I have here? Well, I added or I multiplied it by another x minus 2. So I have to do the top. I have to do the same thing to the top. Now let's look at this one. what do I go from this denominator to get to this new one? Well, I have x plus 2, x minus 2, but here I have x plus 2 squared. So that means I have one more x plus 2. So I'm going to have to multiply that numerator by x plus 2. Now that my denominators match, I can come under here and combine. Since the denominators match, I only need one of them. I'm going to put these under the same denominator. And up here, I have 6 times x minus 2. Now this is a minus, and that's going to be important. Minus 2 times x plus 2. So let's simplify. Now this is a review of previous sections. I'm going to distribute first. So right here, and my denominator is still going to be the x plus 2 squared over x minus 2. When I distribute here, I'm going to get 6x minus 12. When I distribute here, I am distributing a minus 2, a negative 2. So this is going to be minus 2x, and then negative 2 times 2 will be minus 4. Okay, so let's combine. 6x minus 2x is 4x. Now a minus 12 and a minus 4 gives me minus 16 all over x plus 2 squared x minus 2. And just like in the last example, I do need to factor this and see if I can cancel. So what's the greatest common factor for 4x and 16? Well, 4 will go into both of those, so I could factor that as 4 times x minus 4 over x plus 2 squared x minus 2. And none of these things cancel, so this is going to be the simplified version of your answer. Okay, this is going to take some practice. Just go slow, work your way through it, okay? I want you to work on page 90, numbers 33 through 41. I suggest just do the odd ones first because these problems are big. You know, you're not just doing the new thing, you're doing that factoring that we just learned, and that's a lot of new things all together. So it's layered, but you're getting a lot of practice on that factoring, which is good, and you're just adding a little bit of new thing to it. So do 33 through 41, the odd. Check your answers. If you have problems, let me know. If you want to drop a number down in the comments, I will work those problems and put up a separate video for you. If you're in my class, naturally you can just come to my desk. That would be the ticket. So we have one more video coming up. That'll be CA12, and we're going to look at complex fractions. So that's going to be a fraction over a fraction. That should be fun. That will wrap up chapter 1, and we will be ready to start with the real college algebra. I'll see y'all in CA12.